All right, Lily, welcome back. How was your break time? Did you manage to write some sentences in that break time?
I wrote, no, I draw, I drew,
I drew. Let's see, what did you draw?
and read one more time and thinking.
Okay, so I
Mhm.
want to understand the advantages and disadvantages of the parallel and the series circuits. So, let's do that together.
We didn't learn about series, did we?
No, we didn't, but we will do it now.
Okay.
Okay, but do you remember the parallel? Can you give me a advantage and a disadvantage of parallel?
Mm, Okay. Advantage, wait, I have to, advantage. Advantage is like in parallel circuits, if one of them blow up, but still other will work because it has more than one path. So
Very nice.
electric
Very nice.
to
Do you understand this one? Can you remember it? You remember it for
yes.
Monday. Okay, and then one disadvantage of the parallel.
Disadvantage is if we have a series circuit and parallel circuit. Series circuit, if you have two batteries and one light bulb, it will be bright. But brighter than one battery and one bulb. But in parallel circuit, if you have one bulb and one battery, it'll be bright, but if we add one more battery, it will not be brighter.
Good, very good. Adding another source, adding another battery will not increase the brightness.
Mhm.
Okay, again, you understand this? I want you to remember this. Memorize it for Monday. Now let's look at
Okay.
the series. I'm going to go to the whiteboard
I
as
see
well.
my book.
Lily, you said you didn't write it. You said you drew it, right?
Yes?
Can you show me? What did you draw? I'm just curious. Okay, so parallel, advantage, which is brighter.
This is the Korean meaning.
Okay, let's go to our series. Let's do an advantage of it and disadvantage of series. Now I'm going to ask you to switch on the thinking brain.
Mm-hmm.
And let's do here. Let me write as well. So, advantage of a series is that
Mm-hmm.
we can increase the brightness. How?
By adding more batteries, more
Nice.
sources.
Adding a battery will increase brightness. That is the advantage. Now, disadvantage of series. If we have more than one bulb, if we have two bulbs in series,
Mm-hmm.
and one of them is not working, one of them is exploded, it's broken, what will happen to the other one? Will the other one light or not light?
Not light because there's only one path.
There's only one path, so that path is broken, so it will not
Mm-hmm.
light. So a damaged bulb will cause a broken circuit. Okay, so that's the series part. You just did for me, you did the parallel, advantage and disadvantage, and now can you explain to me one more time the advantage and disadvantage of series?
So advantage is if we have if we have two batteries and one light bulb, it'll be bright. But if we add one more battery, it'll be brighter than before.
Nice.
And disadvantage is if we have two light bulbs and one battery, one of the light bulbs blown up, but the other one will not work because it has only one path. So that path is broken.
All right, perfect, Lily. I hope a nice way to study this and memorize this is to draw a table and write this in the table, and then you can practice it in your head. Now, one more thing quickly, I want to compare. Now, I just want to compare a quick series circuit and a parallel circuit. If you have, let me just open here quickly. Here is your battery, and you have two bulbs. Right, there is one and there is two. Now, we are not talking disadvantage and advantage. We are just comparing the two, okay? Here is the parallel. I want you to tell me which circuit will show brighter bulbs, the series or the parallel. This is a little bit of a confusing question, and that's why I think they will ask this question in the test. And I want you to remember the answer here. Which circuit will be brighter? They have the same number of batteries, they have the same number of bulbs. Which one will be brighter? This goes back, I'm going to give you a little bit of a hint. It goes back to three things that we need to consider when we are looking at the brightness of the bulbs. Number one is the number of batteries. Number two is the number of bulbs. And number three is the arrangement. Is it series or is it parallel? So this one, I need you to remember that the parallel will be brighter than the series. Okay, can you make a sentence for me? Which of these two circuits?
Parallel will be brighter than series circuit.
All right. So that is what I wanted to make sure you understand.
Why?
Why is it going to be brighter? Lily?
I don't know.
If we consider adding, let's add another bulb. If we add another bulb here, so now we are adding a third bulb to both circuits. There is the one that I've added in series. By adding another bulb, I am increasing resistance, right? A bulb is a resistor, so I'm increasing the resistance. That means the current will be less. All of them will go down. Whereas here, it will not. If
There's only one.
Say again?
Because it has only one.
So I'm adding only one. I'm adding an extra bulb on both circuits.
Because one wire has one light bulb.
So here the resistance is increasing. I'm going to say R up. R is resistance. Resistance is increasing. Here in the parallel, I'm not increasing the resistance. Remember,
Why?
So
only 111, and there are three of them? I don't know.
Because remember the path. There is many paths that the current can flow. There are three paths that the current can flow. Path 1, path 2, and path 3. Here there is only, on the series, there is only one path. If you remember the disadvantage of the series, if one of them goes out, all of them go out. But here, There are three paths. So by adding a resistor in parallel, you are not increasing the resistance of the circuit. And because you are not increasing the resistance of the circuit, the brightness will stay the same. So now if we add another one, if we add a fourth, which brightness will stay the same? Which brightness will decrease? I'll ask the question again. If I add a fourth bulb on
So one more, like not four of them, like four.
a fourth,
TH.
yes, one more. If I add one more, and that will be the fourth bulb, which bulbs or which circuit will decrease in brightness and which circuit will remain the same?
Parallel will be same and series will go down.
Yes. Can you understand? Lily, it's difficult to understand why. It is difficult to understand why, but I just want you to remember that that is the way that it is. At a later stage, you can learn why.
Okay, wait, I have to draw that. Just wait, I don't have so I'll just draw here. Okay. 2, 1, 0, S and a P.
You can draw it, yes, but then we will also write a sentence about it.
Okay.
Tell me,
this will be brighter.
tell me when you are finished with the drawing so we can write the sentence together.
Okay.
All right, so we are adding bulbs. So let's write here, adding a bulb to the series circuit. Adding a bulb to the series.
Should I write that?
Yes, please write this one with me. Adding a bulb to the series circuit will decrease the brightness.
Series circuit will decrease the brightness.
Okay, now can you make a similar sentence about the parallel? Adding a bulb to the parallel circuit.
Oh, this is parallel circuit and adding a bulb to the parallel circuit will stay the same in the brightness.
Yes, correct. I need you to remember that, Lily. Study this one.
Okay. A bulb to the parallel circuit will
remain
the
the same.
same.
Will remain the same.
Will remain the same for the brightness.
Okay, so Lily, here in this example, we added the bulbs, right? We increased the resistance. Now, what if we kept the bulbs the same? So we will stay with three bulbs. What if we change the number of batteries? What do you think will happen then? So
in same circuit like this?
Same circuits, yes. So I'm going to, let me just erase the sentence and the square. Okay, here are our circuits. I'm going to add one battery on the series, add one battery on the parallel. What do you think will change? How will the brightness change?
Series will get brighter and parallel will stay the same.
Yes. Yeah, okay, good. Lily, I think you understand well. Okay. That's the end for the circuits. Is there any other question you have about the circuits?
No.
Okay. Let's talk a little bit about forces. You mentioned
Yes, I love to talk about forces.
You love to talk about forces. Okay, let's think
Yeah,
about
because I'm not good at it. So there's an apple.
Yes, let's look at some examples. There's an apple falling from a tree, is that right? Or is the apple roll? What is the apple doing?
Apple. It says there, an object will fall to the ground unless it's supported or held by another force.
Okay, so I'm going to draw the apple here. Let's draw a red.
Yes.
And there are forces acting on the apple. Now, I think you don't need to calculate the forces, right? You just need to explain the forces.
Yes.
So, the apple is falling. That means it's moving down. So I'm going to draw a down arrow. What is that force that is making the apple fall down?
Gravitational force.
Good. But at the same time, there is also a force upwards. Remember earlier we were talking about waving our hands through the air.
Yes.
Okay. What is that force? That is air resistance.
Air resistance.
All right. So those are the two forces that are acting on the apple. But which force is greater? Is the air resistance greater or is the gravitational force greater?
Gravitational force.
Because it's moving down, the gravitational is greater. Unless it hits the ground. Once the apple hits the ground, then there is no more air resistance, right? So then this one goes away.
Yeah.
Gravity is still acting, but there is a floor, and the floor is pushing the apple up. And these two forces are now equal. Because the apple is not moving, these two forces are equal. Remember, if there was no gravity, then the apple will float up into the air.
Like in space.
Exactly. Space doesn't have gravity. Okay, so let's look at do you have any other questions or can we go to another example?
My mom is sending you the picture of the books.
Okay, let's have a look. Because I actually want to talk about, let's do quickly an aeroplane.
Okay.
So here, oh there, I got the mess. Let's see here.
이거 뒤에 다 찍었어?
Okay, here we have a swimmer. Let's quickly look at the aeroplane. The aeroplane is not in the book, but there are 4 forces on an aeroplane. Okay, there is the aeroplane. Lily, I'm going to draw an arrow down because there is what force acting on the aeroplane?
Gravitational force.
The gravitational force. Then there is also a force pulling the aeroplane backwards, which was the same as the apple. What was the apple?
Air resistance.
Air resistance. Now, how does the aeroplane stay in the ground? If there is a gravitational force, there must be something acting up as well. And that force is called lift. This one is from the wing. That's why the aeroplane has wings. It pushes the aeroplane up. Okay? Now this air resistance at the back. The aeroplane is not moving backwards. The aeroplane is moving forward. So there must be a force moving forward. What would that force be? That's opposing.
Frictional force.
No, the frictional force is the air resistance. The air resistance is frictional. I will write
I
it.
don't know.
Air
Backwards.
resistance is friction. Okay, but because the aeroplane is moving forwards.
Is friction.
Lily,
Yes.
how does the aeroplane move forward? What is making the aeroplane move forward?
Engine.
Yes. So the engine is pushing the aeroplane forward, and that is called thrust.
So engine is what?
Engine is making the forward force. It's pushing the aeroplane forward. If there was no engine, the aeroplane will not move forward. Okay, so you need to understand which forces are greater, which forces are smaller, and which forces are equal. So, I'm going to ask you, I didn't label the bottom one, the gravitational force. If this aeroplane is flying in the sky, right? It's moving forward, but it's not moving up and it's not moving down. Which forces are equal?
Lift and gravity is equal?
Yes, lift and gravity is equal. What happens if the gravity is greater than the lift?
It'll fall.
It will start to go down, right? It will start to go down. The aeroplane needs to go down when it's landing, and so they reduce the lift and gravity will increase. What about the thrust and the air resistance? Which one is greater?
Air resistance.
Air resistance. Can you make a sentence for me?
Air resistance will be stronger.
Why?
I think.
Why? Why do you?
Because.
So now we are comparing these two. We are comparing the air resistance and the thrust. Why did you say
Because air resistance is making the airplane go forward, but engines is making the airplane go forward. So, I don't know.
So the thrust, the forward force, is greater than the air resistance.
Okay, so thrust, engines, bigger, air resistance. Yeah, I don't know. Newton's first law.
Newton's first law.
It's not in the book.
It's not in the book.
Unless force applying it, I only remember that.
Unless a force is applied to an object, the object will remain stationary. Unless a force is applied, the object will remain as it is.
Wait, I have to write. Newton's first law. Can you repeat that slowly?
So, an object will remain.
An object will, yes.
Will remain moving or stationary unless.
Stationary.
An object will remain moving or stationary unless an external force is applied to it.
External force is applied. Good.
Okay, so now let's understand what that means.
Yes.
I'm trying to think of an example. Okay, we have a car. A car is stationary. Before we get into the car, before we drive, the car is stationary, right?
Yes.
And the car will remain stationary unless a force is applied to
Force
it.
applies what?
So, I mean that's quite obvious. If we don't move the wheels, the car will not drive. But let's look at the opposite. What if a car is already moving? The car is moving on the highway, right? So
Yes.
the object is moving. What is the external force? Why is the car going to eventually stop unless an external force is applied to it?
Because
So
force
I always like to,
is
Lily,
pulling for the
I-
backwards.
I always like to draw the object
A car?
and then draw the forces on the object. So there's our car,
Oh.
right? And there is the road because the road is giving friction.
Friction.
Okay, good. There is also gravity. We are just interested in. So the engine is an external force. It's going to make the wheels move forward, right?
Yes.
But if we stop the engine, so the car is rolling, is the car going to remain moving forward? Remember, Newton's first law said the object will remain moving forward unless there's an external force. So what are these external forces that make the car stop eventually?
Wheel.
The wheels are making friction, yes. So there's friction and there is air resistance.
Mm. So the car is moving this way or this way?
The car is moving towards the right.
Okay.
Moving. Okay, Lily, Newton's first law says that this car will remain moving forward unless an external force is applied to it. So if we remove, how can we remove the air resistance?
How can we remove?
Yeah. We want to remove the external forces because look at Newton.
Stop.
Look at Newton's first law. Look at that sentence.
Yes.
It says there that the car replace object with this car. Can you read the sentence for me? With the car will remain moving.
The car will remain moving or stationary unless external force is applied on it.
Okay, so this car, we said it's not stationary. So this car will remain moving unless there is an external force. This car will only remain moving if we remove the air, put it in the vacuum, in space.
Wow.
And then how do we remove the tire frictional force? We can only, if you can imagine, replace these tires with skates, like skating on ice. Even skating on ice also has friction, but it's less than the tires on the road. So if you can imagine this car is on skates, on ice.
Yes.
It will continue for a long time. There's no external force acting on it. If it is in a vacuum.
Yeah.
Okay, Lily, I want to think of another example here. Let's do one of your examples in the book.
Book. What is lubricants?
Lubricant. Lubricant
Yes.
is a liquid that, example, if we put the lubricant on this road here, I pour oil. Oil can be a type of lubricant. If I pour oil onto this road,
Yes.
Lily, will the frictional force increase or decrease? It will
Decrease.
It will decrease. So a lubricant reduces friction.
Reduce.
Reduces friction. A lubricant reduces the frictional force. Okay, here I saw in your book here there is the example of a book on the desk. Lily, do you have a book on your desk right now in front of you somewhere?
Yes,
Okay.
here.
Is it moving? Is it stationary? Put it on your desk.
Put it on my desk.
Your book is stationary, right?
Yes.
Exactly what Newton said. Newton said it will remain stationary unless there is an external force. Your external force is going to be pushing the book. Don't push the book. Is it moving or is it staying?
No.
Is staying stationary?
It's staying stationary.
Okay, let's apply an external force. Push the book. Is it moving?
Yes.
Yes, that's because there is an external force on it.
Yes. So friction is going this way.
Friction is going the opposite to how you push it.
This way.
Lily, you are pushing the book and friction is acting the opposite direction.
So am I pushing this way? So the friction is going this way.
Exactly, yes.
Air resistance.
So there is two.
Yeah, I don't understand the girl picture.
The girl picture.
You can see a girl doing a paper like this.
The girl, she is doing what? As the sheet of paper moves downwards, air resistance opposes its motion and slows it down. There is more air resistance acting on the paper due to its flat shape. Okay. There is also some air resistance acting on the piece of chalk. Okay, so she's dropping a piece of paper in one hand and she's dropping chalk in the other hand.
Yes.
Lily, going back to waving our hands in the air. If we have small hands, if we have big hands, which one is going to be easier to wave?
Smaller hands.
Why? That is correct. Why? Because of air resistance. The bigger hand has bigger air resistance.
Oh.
So that's the same with the paper and the chalk. The chalk is smaller, so it will have less air resistance.
Chalk is smaller than the paper, so it does not have it.
The air.
It has less.
It has less what?
Air resistance.
The chalk has less air resistance, and that's why it moves faster and hits the ground before the paper.
Faster.
Okay, Lily, when you get confused about air resistance, always think about waving your hand in the air.
Waving my hand. Waving hand in the air.
And then you can move your hand into the water. Waving your hand in the water is also a good example.
There's actually water resistance, but my mom didn't send it here, so you can see it from here.
Okay, so imagine waving your hand through the water. Same thing. The smaller the hand, the less water resistance.
Okay, but water resistance.
What is the example in the water resistant example? Is it the submarine there? What was it?
Submarine.
Okay.
And a fish.
And they are both moving through the water?
Yes.
And which one? The question is what? Which one has more water resistance?
So I have what's so wait, so like this.
The
Yeah,
fish.
so if there's a water here, and if I move my hand here, then the water resistance will be there.
Yes.
So
In
it
that
wants to
direction.
pull my hand there, right?
Lily, the water resistance is trying to stop your hand from moving.
From my hand.
So you are pushing your hand forward, the air resistance is pushing your hand back. That's why it's difficult to push.
So my hand goes this way. Water resistance goes this way.
Yes, opposite forces. But your hand force that is moving your hand is greater than the water resistance, and that's why you are able to move it.
And
Unless you put your hand in oil. Oil is very, very thick and very, very difficult to move your
so
hand.
oil is stronger than me.
I don't know how, how strong
Is
you are.
is stronger than the water, right?
Yes, yes, it's even stronger than honey. Or
Oil.
the resistance in the oil is more than the resistance in the water. But Lily,
So in the bird flying, so
I just want to
they're
I just
flying.
want to say another thing about the water. If I move my hand like this, so here's the water with this surface area, right? This surface area of my palm is more than the surface area of this side. So if I move my hand like this through the water or like this through the water, which one do you think will have less air resistance? Water resistance.
This.
Yeah, exactly. Because it has a smaller surface area.
Oh, I don't know where's this, so I'll keep it in mind.
Yeah. Keep it in mind when you are thinking about waving your hand through the water. You mentioned something about the
It
bird.
says here. I have two questions. There's a bird.
Lily, can you go out of the class and come back in? Because after 1 minute it will automatically close. Can you go out and come back in?
Okay. So, if the bird is flying this way,
Forward.
forward, the air resistance is there.
Is the opposite
Right?
direction. The air is
Right?
the air resistance is pushing the bird backwards.
And it says here, I don't understand. How should I show this? This thing.
Let's see there. Water resistance. Water resistance. The frictional force. So this is not the bird. You are not talking about the bird. Okay, let's do the frictional force acting. The frictional force acting on objects as they move through water is called water resistance. Okay, yeah, this is exactly what we were talking about waving our hands. Water resistance.
So if there's cup of water and no cup of water, if I drop it, then it'll the cup it doesn't the cup has no water. If we drop that, it will be faster than what it has the water, where it has the water.
So, yes, that is correct. The one without the water will drop faster, but they both have a frictional force. The water has water resistance, the one with air has air resistance. But remember, it's easier for it to pass through air than it is to pass through the water. Does that
Mm-hmm.
is that making sense? Is it clear?
Yeah.
What about the bird? You started talking about the bird. Did we
It says here to reduce air resistance while flying. Birds have streamlined shape and fly in V-shaped formation.
Okay, so that they are trying to reduce air resistance. So to
Air.
reduce the air resistance, they can go faster if they reduce.
The frictional force, air resistance, water resistance is the
That's all the
is
same.
frictional force,
It's
right?
all this, yes, it's all the same. Friction, air resistance, water resistance, they are the same. Do you have another
Okay,
example there?
says friction between the part of car engine generates heat and cause the engine to overheat. So it goes like this together and it gets hot.
Can you read that one more time?
Friction between the parts of car engine generates heat and can cause the engine to overheat.
Okay, good. This is a good example. So inside the engine, there is lots of moving parts, right? Let's have a look here. I want to show you some pictures. Car engine moving parts. Right, here they are. Let's go to a bigger picture. Okay, you can see these parts, right? They're all moving and
Uh-huh.
exactly like you put your hands together and you rubbed your hands together. These parts are doing the same thing in the car engine. And what happens to the car engine? Does it get hotter or cooler as these parts are moving?
Overheat, so hotter.
It gets hotter because of friction, right?
Mm-hmm.
But do we want our car engine to overheat?
No.
No, we don't want it to break down. So, how can we cool down or how can we reduce the friction of the moving parts? We can add the lubricant, the oil.
Oh.
If you add the oil, then the friction decreases. And then the parts will not have so much friction.
So
And
that's why when we have a road and there is tires, that's why if you go like this, then it gets hotter, the tire gets hotter.
so on the road, if this is the road and the tire is moving,
Like it is doing like this, then it gets hotter, right?
that's true because of friction.
So why is it easier to push? I mean, to push a not like if you push a box, heavy box, it is hard. But if you have wheels, it reduces friction, rollers, and wheels.
Okay, so Lily, if you have a box with no wheels, it is sitting on the floor, right? The box is sitting on the
Yes.
floor and you are pushing it, but there's a large surface area that it's rubbing on the floor. If you put that box on wheels, you are reducing the friction because that large surface area is no longer on the floor. It's just those two pieces of where the tires touch the floor, and that's so much smaller. Only the tip of the tires. So there is still friction, even with the tires. There is still friction, but it's so much less. And so it's easier to push with the tires than to push without the tire. Okay, now I want you to explain that to me. Can you explain
Which
why is
so
pushing a box with wheels easier than pushing a box without wheels?
Because if we have a heavy box and there's a large floor, and if you push it, all of the box is touching the ground. So it has more frictional force that is coming backwards. But in wheels, if we have the wheel, it has less friction because not much space is touching the ground.
Exactly. On the wheel, Lily, how much is touching the ground on the wheel?
Tiny.
Tiny part, just the bottom part is touching. All right, good. I like this. This is even interesting for me. I didn't study science for a long time, so this is review for me as well. Do you have another example that we can check? Lily, are you okay? We are very much over time. I'm worried about your brain. If you are your brain is overheating.
There is weight and mass, and I have to know difference between weight and mass.
Okay, good. Weight and mass. This one is an
There's
interesting.
probably a picture of the book.
Let me see. I think your mom sent me something about weight and mass. Okay. Mass. The best way to remember this is weight is a force.
Weight is a force.
Weight is a
Weight
force,
is a force.
and mass is the kilograms.
Okay, weight is a force.
So actually, when
Mass.
someone asks you the question, "What is your weight?" What do you respond?
My weight is something
Yeah,
kilogram.
which is actually wrong. That is actually wrong. No one should ask you what is your weight because
What is your mass?
it should be what is your mass. Yes, that is the correct way of saying it. But everyone in English, they ask what is your weight. So how do we get from, I'm going to go to the whiteboard again. And let's say, for example, we have here a box. And the box it has a mass of 2 kilograms.
Huh?
Right? The mass is 2 kilograms. So that's the amount of material. The amount of material is the mass. If I want to know what is the weight of the...
Okay, no.
If I want to know what is the weight of this box, then I need to get...
9 point something.
Okay, so now Lily, the weight is going to equal the mass multiplied by the gravitational force, which you said is 9 point something. We can approximate 10. So,
okay, 10.
So 2 kilograms times the gravity is 10. So the weight will be 20 newtons. But I think you didn't study this calculation, did you?
I think we did.
You did. Okay, then it's good to know.
Yes.
So this equation is the weight is the force. So I'm going to write here. Force is equal to mass times gravity. Okay, so do you understand what is the difference between...
Uh-huh.
So now if we let's draw the forces. We know this has a downward force because it's falling, and it has an upward force. What is this downward force, Lily?
Gravitational force.
It's the gravitational force. And this gravitational force is the weight. It's W, which is 2 newtons. Okay, so here it has an explanation in your book. It says weight, there you can see there, it says, can you open to that page?
Weight is blah, 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 blah.
Weight is a force. Weight is the gravitational force acting on an object. Weight is the different at different places. Yes, because if you on Earth, this G is different to the G on the moon. So that's why the weight will be different here and different on the moon.
What is regardless?
Regardless means doesn't matter. It can be this one or it can be this one. It will be the same regardless. So for example, I want to go swimming. Regardless if it is at the beach or at the swimming pool, I want to go swimming. Where did you see regardless?
On mass. The third one.
The third one.
Third
Okay.
bullet
So
point.
mass is constant. What does constant mean? It doesn't change.
Doesn't change.
Constant means it doesn't change. So the mass of an object is the same regardless of where the object is. So if you can imagine Earth or the moon, the mass will stay the same. It will be 2 kilograms. This is not getting bigger, it's not getting smaller. But the weight will change.
Okay.
So your weight, let's look at your weight, Lily. Your weight on Earth and your weight on the moon. What will be different? How will that change? Since we know, let's go back to our equation. Your mass is equal to, what are you, 30, 40?
40.
40 kilograms. If you go to the moon, you are not getting bigger, you are not getting smaller. You will stay 40 kilograms, right? But what about your weight on Earth and your weight on the moon? Weight is equal to mass times gravity.
Times.
So let's look at the Earth first. Earth's G is higher than the moon's G. So which weight is going to be more? Your
mass.
Your weight on Earth or your weight on the moon?
Weight on the moon.
Is going to be what?
Lighter.
Yes, good.
No.
Yes. Your weight on Earth, because you will be heavier on Earth than you are on the moon. Lily, you can even think about when you are floating on the moon and you step on a scale.
Yes.
Is the number going to be greater or less than on Earth?
Less.
Less, because you are floating. You are not as heavy. And that's because of gravity. Is it making sense?
Yes.
Do you think you can explain to me about weight on Earth and weight on the moon?
So.
My weight.
My weight. My weight or your weight?
Okay, let's do your weight.
My weight, I'll say my mass is 40 kilograms. Weight, mass is a kilogram, but so on weight is mass times
gravity.
9.8 whatever or 10. Then it'll be weight. My weight will be heavier than my mass because
No. Wait. No. You said my weight will be heavier than my mass. They are completely different things. You can say, my weight will be more on Earth than my weight on the moon. Can you say that for me?
My weight will be more on the Earth, but not on the moon.
Okay, and why? Why is your weight higher on Earth than on the moon?
Because moon has less gravitational force.
Exactly. Your mass stays constant. It's the gravity that is changing. So with a higher gravity, you will have more weight. All right, good. Lily, any other question? I like this one. I can go on. I can continue. It's still early here in South Africa.
Gravitational force. This one.
Let's see. Gravitational force pulls this man back as he tries to climb up the rocks. Okay, this one is easy to understand. I'm going to draw again on the whiteboard.
And I'll blow my nose while you draw.
Go ahead. Go blow your nose quickly.
I'm back.
All right, Lily, you can see he's climbing the mountain here, climbing the wall. And now let's draw the forces. I told you before, I always like to draw the forces. So there is a gravitational force pointing down because of his weight, right? We said his weight is mass times gravity. Mass times gravity. That is his weight. He will stay still unless he tries to move up. What is the upward force that is making him...
Air resistance.
No. How can the air resistance push him up? What is pushing him up? He's climbing.
Gravitational force.
No, his arms, Lily. His arms are pulling the rocks. And that is what is making him move up. Okay, so I will write here climbing. So, what was the sentence in the book?
Gravitational force pulls this man back as he tries to climb up the rocks.
Okay, so he's climbing, that's pushing him up, and then gravity is trying to pull him down. If he makes a wrong move, Lily, if he steps on a wrong rock and he slips and he loses his grip, if he loses his grip, what will happen? Why will he fall down to the floor?
Because gravitational force is pulling him down.
Yeah, and his hands are no longer holding. His hands are holding, they are providing friction. They are providing a force upward. They are stopping the gravity from pulling him down. Okay. There is one more. Isn't there another one there?
There are two more.
Let's do those two more.
When the swimmer dives, gravitational force pulls him downwards and towards the water.
Okay, but that's the same as the guy on the rock. If the guy on the rock wanted to dive in, remember when you dove, you went to Vietnam. No, it was Laos. You went to Laos, and from that platform, you dove into the water. What was making you...
Gravitational pull.
Gravitational, yeah. Gravity was pulling you down.
Gravitational force causes water to flow downwards. Yeah, same one. And gravitational force speeds up the skier as she skis downhill.
The skier as she skis downhill. Okay. Now the skier, you understand gravity is pulling her down, right? You have skied before,
Yeah.
and your weight is what's pulling you down. Your weight includes gravity. Your weight is mass times gravity. Right? But now there is another force on the skier. What is the force that's opposing, that's trying to stop you from going down?
Friction.
Friction on the ski. The ski is touching the floor, right? The
Yes.
ski is touching the snow, and that is friction. I'm just trying to think, give you a good example. I don't know, Lily, did you ever try to ski with one leg? I think maybe it's
No.
impossible. Maybe it's impossible. You will fall.
One leg skiing.
Because the reason I say that is because if you have your two legs on the floor skiing,
Yes.
that's two frictions. But if you lift your one leg, you are removing the friction from that.
Oh.
But then you lose balance, right? So you remove the friction, but then you fall.
And there's the frictional force can be useful. No, not that. The frictional force between our soles of our shoes and ground stop us from slipping when we walk.
Some shoes, they have a rubber on the bottom, so it's very, very not slippery.
Not slippery.
But sometimes, Lily, some shoes cause us to slip,
Yeah.
and that's because they have very little friction.
Little friction.
That depends on the material of the shoes. That also depends on the floor. Sometimes there can be oil on the floor. What happens if you step on the oil?
You slip.
Why? Because oil removes friction.
Oil removes friction. Oil.
Remember the oil that we put in the car so that the car doesn't overheat?
Lubricants.
Lily, just quickly review for me. Why did we put the oil in the car with the car parts we're rubbing?
Because if we frictional force between the machine and the machine, and if we have frictional force, our car engine will have overheat because of the friction, and we have to reduce that. We can reduce friction by lubricants.
Such as oil. Very good. Exactly. And you said now, if you step on the oil, you slip because there's no friction. Oil reduces the friction. Lily, I think you did really good today. I think I overstimulated your brain, but well done. What are you doing this weekend? Are you going to study more this weekend?
Yeah, and I'm going to Daejeon and have my ballet some tools.
When are you going? Saturday or Sunday?
Sunday.
All right. Lily, good luck for Monday. I want to hear good news when you come back next week. I want you to say the test.
We are having marking day.
Marking day is when?
Next week Friday. I mean Tuesday.
When is your last day of school? Is it next week?
Not last week. Next week. Thursday.
Next week, Thursday. Okay. And then you have 1 week holiday?
Yeah.
Nice. Okay. Lily, I will see you next week, Friday, and you will tell me about your tests and your scores. Good luck. Good luck for Monday. Have a good evening.
Bye-bye.
Bye, Lily.